earthquake ground motion. Slowly you are quantifying the parameter. If you are observing, okay, who is observing this earthquake? Is there is an instrument called accelerometer. So this accelerometer will be located below the ground. If you are taking readings from the accelerometer, this is a graph which shows you that the horizontal is the time in seconds up to how long the earthquake occurs. In y-axis you can see the acceleration. By understanding this figure, you know that there are different types of vibration. Okay, can you now differentiate the types of vibration? P wave is a first type of wave which will be in forward and backward motion. So this will not get much higher amplitude. So this is what you observe in the first part. When an earthquake is occurring, you will be having this kind of small variations. So this kind of things are used in cricket also. There is sneakometer. If the ball touches with the bat, there will be some vibrations, and this vibration will be taken. They decide according to the action. Like that, you can see the vibration here. This is similar way to that. Whatever and how the ground vibrates, you can see the vibration parallelly. Next type of wave is secondary wave. It makes the particle to move in horizontal direction. So this is what you can observe here, that why the amplitude is getting increased. Suddenly the character changes from one scenario to the next scenario. So this affects your structure. Also you can see some type of earthquake will be getting acceleration for 0. This is maximum acceleration of 30 meter per second. You can see this is another type of earthquake which is having an amplitude and acceleration of 15, around 15. The twice of reduction is there. See, the acceleration is always proportional to displacement. If higher the acceleration, there will be higher number of oscillations, and how the amplitude is getting changed, that depends on the soil. Let us look into three major parameters. What do you mean by amplitude? Object is in static mode, it goes to left and it goes to extreme of right and comes to its original position. So this is what is going to happen in the whole scenario. Due to the earthquake, at some point it goes to the higher amplitude and it comes to the 0 and original position. Okay, if you want to find it technically, there are these three parameters. What do you mean by amplitude? Is the maximum displacement from the equilibrium position of an object oscillating around the equilibrium position. This is the definition if any object is vibrating. So this is at 0 mode, and if it vibrates at maximum, it goes here and it goes to the neutral part. So this kind of oscillation says that this object only moves in one direction. It does not go to the negative direction. You can observe from this picture. So if any object is going positive and negative, you can see here it goes to positive and negative direction. But from this observation, you can see that an object is oscillating at only one direction. So what do you mean by amplitude is from 0 part to the maximum portion where it goes. So this is the distance which is covered. So the distance covered is known as the amplitude. And what do you mean by frequency is number of events per unit of time. Example, the fan is rotating in a frequency. For 1 second of time, how much of rotation is known as the frequency. So it can change. An object can vibrate for 1 second half cycle, or for 1 second it can go to and fro. The frequency is like that. If higher the frequency, what happens? For 1 second it oscillates 33 number of time, then what happens? This object is going to get higher acceleration. So frequency is higher, then your acceleration will be much higher. If frequency is lesser, then your acceleration will be much lesser. Okay. Now next component is called period. The time takes to complete one cycle of oscillation. If what do you mean by period is what is the time taken for an object to go to, fro and static. This is known as the time period. For one complete oscillation, what is the time taken is known as period. But frequency is what? Inverse of that. So time period and frequency is inversely proportional. The accelerometer will be always in terms of time and acceleration. Period is time takes to complete one oscillation. Now here you can observe that this starts from 5 and it ends at 11. So what is the time period here? 11 minus 5 is 6. So 6 is your time period. From this figure you can understand there are three types of period. Static analysis, you have number of static parameters. They are Young's modulus, which depends on material. If your material is mild steel, it will be 2.5 into 10 power 5 Newton per mm square. Now, if your material is concrete, 2 into 10 power 5 will be there. According to the material, your Young's modulus changes. And according to the shape of your material, the moment of inertia changes. If it is a rectangular shaped structure, you will be using BD cube by 12 and it is a shape parameter. Similarly, in dynamic analysis, one of the dynamic most important character is time period or in period. So what do you mean by period is inverse of frequency. So for all the buildings, period changes. There is a formula for finding time period which is root of k by m. What do you mean by k is called stiffness and divided by m is called mass. If you are building 10 number of stories or 3 number of stories, then the time period is one of the important parameter which could not be changed. Every object in this universe has a specific time period, and how you can find the time period is first one is stiffness. You have to find the stiffness and the mass. Take an example of yourself. Are you having mass? Yes, you are having mass. You can weight yourself 70 kg, 60 kg or 50. You can weight your mass and you can find your stiffness. How to find your stiffness? According to your bendability, you can find the stiffness. So, try to apply some horizontal force. You stand stiff in a place and apply some horizontal force. What happens? If you can handle 1 kg, then your stiffness varies. If someone can handle 2 kg, 3 kg like that, if someone is pushing you horizontally, you have to be stiff. And how much of force you can hold before you deflect is known as stiffness. So, if you know two parameters, stiffness and mass, you can divide it and root, then you will be getting the time period. So according to that, time period changes. Even I have different time period, each and every person have a different time period. So you should understand your time period. Similarly, whatever you are building, the building has some time period which you can find it in module 2. I will discuss how to find time period for a structure. It could be your G plus 7 building, similar structure like this, or your house. You can find time period for your house. Okay, what is the purpose of finding time period? Why do I need to find time period? There is a concept of resonance. What do you mean by resonance is, if both the vibration, the earthquake, how it is targeting the building is, it is traveling in a form of waves. So one single wave is coming and targeting your building. Your building is in form of a wave called a time period. So if both the external earthquake wave and your time period matches, take an example. Your building has a time period of 2 and your earthquake time period is also 2. If both the thing matches, then what happens? Resonance is being created. What do you mean by resonance is high amount of vibration. So if this happens, definitely the building is going to get collapsed. So that is why, is my building safe under earthquake or it could collapse under earthquake? How to find it? One technical parameter is called time period. The time period might be short, the time period might be normal, and it might be long. So this is known as long time period. What do you mean by long is, this is 0 time, and if it is taking too much of time to oscillate, if this is your building and if any horizontal force is given, if it is taking 3 seconds to make one single cycle, is known as a time period. If your building oscillate quickly, and according to this your time period changes. So this is what it is written here. If t is long, it is taking 3 seconds to make a single oscillation, single period of cycle. Now that is what the definition is given here. Time taken by a wave to complete one cycle of motion is called period. So this is indicated by a letter called t. In general, earthquake shaking ground has a wave whose period may vary according to 33 seconds. So time period unit is second. So your building should not come under this time period. If you are making your building, if you are going to construct in design, you have to make sure that your building which is not falling under this time period. How they are building earthquake resistant structure, and this is what I explained in previous class. In Bhuj, there is a hospital built which can handle an earthquake of 8.5 Richter. How they are constructing those kind of hospitals? They design. How they design is first they find the time period of the hospital, that is inbuilt character, and they will check the earthquake. So this is the earthquake time period second. They will be making sure that either the building time period will be less than or greater than 33 seconds. This is an example. A statistic is being taken, and if your building is 3 to 5 story, if you are constructing that, and your soil is this x-axis is called depth of soil and y-axis is called damage structural integrity. What do you mean by that? They are studying, the people who are studying the National Disaster Mitigation Agency is provided in India. They are monitoring the earthquake in and around the India. Around 113 centers are available, which across throughout the India from the north to south they have provided the centers. Okay, what these centers are doing is they are installing the seismometers and accelerometer. They constantly monitor during the earthquake, after the earthquake. After earthquake, how much of structure has been collapsed? They will get the statistics. Without getting approval, no building will be constructed. They have the statistics that how much of building got approval and how much of building is existing. They have that data. What they do is after the earthquake, how much of building is just cracked and is it possible to get occupied, and how much of building is partially collapsed, which rehabilitation is required, and how much of building is fully collapsed. So they will take these three data and they will understand that if your collapsible building, if 100 number of buildings collapsed, only tall stories that are more than 10 number of floors, more than 15 number of floors, structures is only getting collapsed, they will take the statistics and they have made in a particular earthquake and they have given this data. Earthquakes depends on the soil also, which I have discussed in last class. If the soil is very weak and poor, your building will vibrate much higher in amplitude. If your building is located in a strong soil, then your building will not get vibrated to higher amplitude. Only slight shaking will be there. When a vehicle is moving in a bridge, you can observe some slight vibration. That might of vibration might be there. So when they are looking into that much of statistics, the y-axis depends on structural damage integrity. What do you mean by that is, if your building is 50% of capacity after an earthquake, then it has been measured. Note that this is 0 meter of soil and 300 meter of soil depth. Below the earth, you imagine that 300 meter of same soil depth is being available. 3 to 5 story building which is getting higher number of structural integrity problem, that is 30% of the structure getting damaged in the soil level of around 50. If your soil level below the ground is up to 50 meter height and you have different soil, then the structural integrity is only 25%. But if you take 10 to 14 storied building, you note that the depth of soil is 200 250, then you are having structural integrity problem of 35%. And you can see number of height, a 2-story building, 4-story, and like that you have different number of stories. Okay, earthquake is same for all the story. In a state or in a zone, if earthquake is generated, wave is generated, all the building have the similar earthquake. The earthquake wave is not going to get changed, but your building might get changed. In a place of a city, you might have a G plus 20 structure of only 4 or 5, but you will be having G plus 3 story structure in 40,000 or 50,000 building. So the earthquake is same, but your building is different. So your structure is different. So according to your height of your structure, your building might get collapsed. So this is what is been highlighted here. Even within the range, some earthquake waves are stronger than others, and the intensity, which is primarily meant on magnitude of earthquake, epicentral distance. Okay, the single earthquake have this much of following parameter which could change the earthquake. In Bangalore, if you go towards the river area, the soil will get changed. So the earthquake is same, but wherever it is traveling, these are the rock strata. If you go to Uttarahalli, there are mostly rock strata available when you are going to get constructed. So there, if any earthquake might occur, it will be not getting much high vibration. So it will be slight vibration even though you cannot perceive. But if you go towards the Mysore side, what happens? Your soil will be getting strong, will be much diluted, and what happens? More the softer the soil, the amplitude is going to get higher. So this is what first thing. First thing is magnitude of earthquake is 1 point of managing the intensity. Second one is epicentral distance. Third one is type of ground. This is what I am highlighting now. According to the type of ground, the earthquake intensity gets changed before reaching the location of interest. So wherever your location of interest, this plays an important role. Okay. These are the different types of structure. In a city, you take in each and every city, you will be having, or in a street, in every street you will be having elevated water tank. If you are having 40 number of street, you will be having 40 number of tank in your structure. Note that the elevated water tank will be having 4 seconds of time period. So what do you mean by T is called time period, and unit of T is second, similar to time. So note that time and time period is different. There are two similar parameters in dynamic analysis. One is known as time, general time, which is known as how we will measure the time, minutes, seconds and hours. This is general time which we look into the clock. But in dynamic analysis, you have a time period. So you have both the time. So you should not confuse with that. Whatever you are looking in the clock is known as time in seconds. But in structural dynamics, time period. So you have time period. Period is known as time period and its unit is also second. So for an elevated water tank, around time period of 4 seconds will be there. If you are having a G+1 story, you will be having a time period of 0.05 second. And if you are having a concrete chimney, this you can see in RMC plant. If you visit in our RMC plant, you will be having the chimneys. In one chimney, they will be having Portland cement. In another chimney, they will be having fly ash, and like that. They will be having different number of chimneys. So they have different number of time period, which is 2 seconds. And for a dam, you will be having a time period of 0.8 seconds. And if you are having suspension bridge, which will be having a time period along 6 seconds. Okay, your earthquake is coming with a time period of 20 seconds. Each structure will be getting collapsed. Now you imagine, take an earthquake of 20 of time period. Is any structure is going to get collapsed here? Identify all the time period of a structure. One story is having 0.05 second, and this is a multi-story structure which is having 1 second. No way you are having 20 second of time period. Now, if the earthquake of time period 20 second is arriving, no structure will get damaged. Now, imagine that your earthquake wave is 4 second. Now, which structure is going to get damaged now? This dam is having a time period of 0.8 second, which is nearing 4 second. Elevated water tank. Elevated water tank is having 4 second. So due to that earthquake, the elevated water tank will get collapsed. So this is what you can find by this. So by this picture, you can understand that if any earthquake is less than 1 second, it is going to damage all the G+1 or G+3 building. Earthquake wave, which is more than 1 second, then it is going to affect the multi-story building. It might be G plus 10 or like that. If your building is more higher, it might be 40 story or 50 story, then it is going to get affected only your earthquake is more than 2 seconds. The time period is, if it is more than 2 seconds, then the building get collapsed. So parallelly you can see the amplitude. What is this? In previous slide I have shown you amplitude. What do you mean by amplitude is in a cycle, what is the peak of the vibration is known as amplitude. So what do you mean by period? What is the single oscillation time? Okay. So the T value depends on flexibility and mass. T is known as root of K by M. What do you mean by K is stiffness? Stiffness is otherwise called flexibility, and M is known as mass. The value T depends on flexibility and mass, that is stiffness and mass. More the flexibility, the longer is the T. What do you mean by T is time period. If your building is more flexible, which of the building is more flexible here? Suspension bridge. Suspension bridge is not a stiff structure. It will be oscillating even if high cyclone is there. So it is a flexible structure. They have longer time period. That is why you can see 6 seconds. And which is stiff structure, which is known as a G plus 1, which is very stiff. There is no flexibility in that. And taller buildings are more flexible and have longer and larger mass. If you are increasing the tallness of the structure, automatically what will get increased? Mass is going to get increased. If one floor is there, you will be having around 20 ton of load. Imagine that 1 cent of building. You are building 1 cent of house, you will be having around 20 ton of load. Note that if you are building 20 story, 20 into 20 you have to multiply. 400 tons of load will be there. Then mass will get increased. Next topic is seismic zoning map of India. According to the earthquake which occurred in past, the seismic monitoring centers, which I will discuss, there are number of centers. They have arrived a map for India. So you can visit the website Maps of India, seismic code, which helps us to improve the behavior of the structure. Why you need to make a map is India is divided by number of states, and the seismic map will not abide that state. So it is going to get analyzed only by the fault zones. Wherever the fault zone is available, at that point of area you will be having higher zones, and the zone is different and states are different. So you have to understand only in the zones. It has been divided into zone 2 to zone 5. What do you mean by zone 2 is least effect due to earthquake. There is very less possibility of earthquake is zone 2. And what is zone 5 is there is a high chance of earthquake which can come in 50 years of time period. It is called zone 5. And why you need to make seismic zone map is you need to improve your behavior of structure and without significant life and property loss. If you want to make this and achieve this as a designer, then you need to look into seismic map of India to help the designer during planning, designing, detailing and construction. Note that if you design, you have to parallelly detail. During planning also, seismic zone or this Indian Standard Code. Currently I have shared you in the group IS 1893. Most important code book. You have to read this each and every class which is given in IS 1893, which implies in planning, which implies in design, detailing and construction. They take into account, okay, how the seismic zone map is being generated is according to seismology, level of seismic risk, building topologies, material method of construction used. These are the things which are taken into account, then the seismic zone map is being done. And what is the purpose of doing that is you can reduce mitigation and impact. If you follow this map and design or plan, definitely your building will perform much far better than the building which are constructed not abide and minimizing the damage of the structure, safe and urban planning. If you are planning any layout, in Bangalore you can see number of layouts, and all the layouts will be planned, and the town planning in charge will be there, and they will be planning according to the seismic zone map also. If any zone which is falling under high seismic effect, they will not give approval for that site or that layout. So they will say that this is seismically prone zone, no constructions for G+20 is being allowed. So at the approval point, the government will stop that. So by following this, you can make a safe construction. If you want to study the earthquake and related study, these are the list of code books which are available in India, and 6 number of code books are there. What is IS 1893 part 1 is earthquake resistant design of structure. This is used for design engineers of concrete structure and general structure. And IS 4326, which is earthquake resistant design for construction. For designers, they use IS 1893, and if you are constructing, you have to use 4326. IS 13827, this is improving the earthquake resistant earthen building. What do you mean by earthen building is which is constructed by using soil, only clay material, and they will construct. So you can use the eco-friendly building material and construct. I have seen number of students making the project in earthen building. What do you mean by earthen building is, see, if you are constructing a RCC structure, you will be definitely using steel and concrete. Okay, how the steel and concrete is being made? Without cement, can you make concrete? No. Without heating, can you make steel? Not possible. You have to take the iron ore and you have to heat. Then you have to split the material. If you are heating, what happens? More number of carbons will be there. If you are making the cement, cement can be only made, you know the process of manufacturing of cement. Limestone will be burned in around 1800 degrees centigrade. During burning of the limestone, the smoke gets evolved and it damages the environment. If you want to make sustainable construction, then you have to go for earthen building material 13828, which gives the improving earthquake resistant for low strength masonry building. What do you mean by masonry is, if you are constructing building by using red brick, hollow blocks or solid blocks, if you are using these three material, then you can use IS 13828 and IS 13920, which is used for ductile designing of reinforced concrete structure. All the G+10 story structure which will be having shear walls. Have you heard about shear walls? Shear walls will be only designed by using this code book. This is for RCC. Shear wall is only built to resist the seismic force, and it is available in IS 13920, and last code book is 13935, which is used for repairing and seismic strengthening of building. This is used for post-earthquake. Rest of the code books are used for pre-earthquake. If you want to prevent earthquake, these 5 code books should be used. And after post-earthquake, the one code book is there, IS 13935, which will be used for strengthening and repairing. Okay, this is the map. You can see the zones. Can you spot out where you are currently located? You are located in Bangalore. It is coming in Karnataka, and at this place, around this place, you will be having Bangalore. What is the zone? Zone 2. Zone 2 is the safest zone where least number of earthquakes might occur. Is anyone located in zone 5? What is zone 5? Zone 5 is this Mizoram and Nagaland, Bhutan, Bihar, Uttarakhand, Himachal Pradesh, Jammu and Kashmir. These red zones are, and Gujarat. When you are constructing, you have to make sure that it is high time to make only seismic resistant structure, and these are the places where they have zone 4. Can you understand why only these parts are under zone 4 and zone 5? What is zone 5 is red, zone 4 is orange. Why these parts are only orange and red? Because you have fault zones. So wherever you have this zone, there are high possibility of seismic risk. And rest of the places are very much safe. You can see all the places in Deccan Plateau are under zone 3 and zone 2. In India, totally 59% of landmass is prone to earthquakes of different intensities. Only 31% of landmass is safe out of 100%. And as per seismic zone map of India, total area is classified into 4 zones, which I have said that zone 2, 3, 4 and 5. Zone 5 is the most active region and zone 2 is the least. If you are constructing any building in zone 5, which is having 11% of area, total in India, 11% of area is covering under zone 5. At zone 4, 18% of land has been covered and zone 3 maximum of 30% which is covered. So all these 3 zones are considered as prone zones of earthquake which should be designed by earthquake resistant structure. National Center for Seismology, that is NCS, which is a center under Ministry of Earth Science. You have separate minister. See, if there are Constitution of India, you are having different ministers. Ministry of Earth Science have a separate minister for that. So under them, they have National Center for Seismology managing that, and National Seismological Network and 115 observation centers spread across the country. This is what I have said earlier. Totally we are having 115 seismic center, and in 1 or 2 years of time in RRC we are planning for one seismic center which could observe all the earthquakes which occur in and around the place. This 115 observation center is not only government. There are some colleges which are involved. IISc is one of the colleges who are having this report book. So take the Annex E. You can see the different types of town. We are there in Bangalore. Bangalore is in zone 2. If you are looking into the seismic map, it will give you the overall idea only. But if you want to know individual town, you can look from here.